Okay, so let's talk some more about the Junos OS control and forwarding planes. We talked previously about how modular the Junos OS is and the separation of the control and forwarding planes. We know that the processes that control routing and switching are clearly separated from the processes that control forwarding of packets and frames. The separation of these processes are what makes it so easy for Juniper to use the Junos OS codebase to support many different service platforms and still retain a common codebase. This example shows the basic view of how the Junos OS processes traffic from the perspective of the control and forwarding planes. The control plane, as shown here, runs on the RE, or routing engine. The RE is the brain of the platform, as we mentioned in the last section. It is responsible for executing protocol updates and managing the system. The RE runs various protocol and management software processes that reside in the protected memory space. The RE is based on an x86 or PowerPC architecture, depending on the hardware platform. The RE maintains the routing tables, bridging table, and the primary forwarding table. The RE connects to the PFE, or packet forwarding engine, through an internal link. Even though all the Junos devices share a common codebase, the actual hardware components that compose the control and forwarding planes will vary quite a bit from different platforms. The PFE will usually run on its own hardware within the device, and it's responsible for forwarding transit traffic through the device. But not all Junos devices have separate hardware for the PFE, like some of the smaller, less powerful devices, but most of the larger devices do. Because the RE provides the intelligence of the device, the PFE can simply carry out its instructions to forward frames and packets with predictable performance and stability. In other words, the PFE doesn't have to think about what it's doing. The RE has already done that, so the PFE can simply perform the action. Because of this design, Junos devices can perform high availability functions like graceful routing engine switchover, unified in-service software upgrades, and non-stop active routing. The RE handles all protocol processes in addition to all of the other software processes that control a device's system management, user access, interfaces, and chassis components. As we mentioned before, all of these processes run on top of the FreeBSD Junos kernel and interact with the PFE. The Junos software directs all protocol traffic from an interface to the RE for processing. The RE also provides the Junos user interfaces, the CLI and the JWeb interface. These interfaces run on top of the Junos kernel and allow a user access to control the device. Let's talk a little bit more about the packet forwarding engine, or the PFE. The RE controls the PFE by providing accurate and up-to-date Layer 2 and Layer 3 forwarding tables, and by downloading microcode and managing software processes that reside in the PFE's microcode. The RE receives hardware and environmental status messages from the PFE and acts on them. The PFE is the core component of the forwarding plane. The PFE will methodically forward traffic based upon its own copy of the forwarding table. The copy of the forwarding table that the PFE uses is synchronized with the information in the RE's forwarding table. Having its own copy of the forwarding table allows the PFE to forward traffic more reliably and more quickly, and eliminates the need to consult the RE every time a packet needs to be forwarded. Using a local copy of the forwarding table allows the PFE to continue normal forwarding even when the RE is experiencing heavy load or instability. The PFE is also where some more advanced services are implemented, like QoS, policers for rate limiting, and stateless firewall filters. Now, we mentioned transit traffic before. To clarify what we mean when we talk about transit traffic consists of all traffic that enters an ingress network port, is compared against the forwarding table and is forwarded out an egress network port towards its destination. Transit traffic can be both unicast and multicast traffic. There are a few exceptions to what transit traffic is. Certain packets addressed to the chassis itself, for instance, or ICMP messages. Traffic like routing protocol updates, telnet sessions, pings, trace routes, and any replies that come from traffic sourced from the RE. These types of traffic are not considered transit traffic because basically these kinds of traffic terminate at the device, or they are addressed to the device itself, as opposed to traffic that is just passing through. The Junos OS also has a feature designed to protect itself from these kinds of exception traffic. The Junos OS has a non-configurable built-in rate limiting feature. This feature resides at the link between the RE and the PFE. The Junos OS will begin rate limiting data over this link when the volume becomes high and congestion occurs. This helps to protect the OS from denial of service attacks and protects the integrity of the system.